The broadcast is now starting. All attendees are in listen-only mode.
All right, good morning, everybody, and welcome to Intertech's webinar on ASTM F3561. My name's Laura, and I'll just be the host today. Before I let Travis and Andy go ahead and get started, I just wanted to remind everybody that they have joined on mute. So if you do have any questions throughout today's session, you can just go ahead and type them into the question box on your control panel. And then within probably 24 to 48 hours, our team will follow up with you and get those all answered. Also, we are recording today's session. So a recording of the audio and the slide deck will be emailed out to everybody who registered for today. But with that being said, I will go ahead and pass it over to Travis to get started. Thank you.
Thanks, Laura. Welcome again, and thanks for joining us today on the webinar on ASTM F3561. This is forced entry resistance of fenestration systems after a simulated shooter attack. Today's webinar is going to be presented by two individuals, myself, Senior Manager with Intertech for the Security Research Center here in York, PA, and Annie Holstein, who was the manager at our Middleton, Wisconsin facility for our Evaluation Services Group. So just to give a little background here on myself, I'm a graduate of Penn State University with a Bachelor of Science in Mechanical Engineering Technology. I've been employed with Intertech for 25 years. And again, as I mentioned, I manage the Security Research Center, which handles the blast, ballistics, and forced entry testing at our York site. And I also manage our structural systems testing group, as well as our insulated glass and safety glazing testing services. Again, Andy, who's going to be presenting here as well today, he's a graduate of the University of Wisconsin with a PhD in engineering. He is a licensed professional engineer in the state of Wisconsin. And he's been employed with Intertech for 8 years for both testing and certification of numerous building products. And again, as I mentioned, he manages our Middleton, Wisconsin Evaluation Services Group. So again, this presentation today, what we're going to do here is I'm going to first start and give a brief description on the method itself, which is ASTM F3561, and then I'll hand it off to Andy, and Andy will talk a little bit about the Intertech certification, and that would apply to ASTM F3561. So let's jump into here first the general scope on this standard itself. So ASTM F3561 is a standard that was just recently approved back in August of last year. So still a fairly new standard. And as I go through my slide here, I'll probably mention that a couple of times, is that this is still a fairly new standard that we've just as a test lab conducted a very small amount of testing so far on the standard, just because it's so new. The standard itself is primarily intended for building products such as windows and doors and glazing and modular panels themselves for forced entry protection after sustaining an active shooter attack. As far as these specimens go for the standard, based on construction, you need to have a minimum of 3 specimens per product type tested based on this standard. So as an example, if we're looking at a single door construction, you would have to have, again, 3 specimens of that door tested. The first 2 specimens would be tested for the glazing or panel weakening testing along with the impact tests. And then that 3rd specimen would have to go through what's called lock weakening and then forced entry impact tests. So again, 3 separate specimens would have to be tested as part of the standard on product types. The systems are to be full size and representative of production with all required hardware. And one of the other things within the standard it states is that there are prerequisite standards. ASTM F476 is one, and that is for swinging doors. ASTM F588 is for window systems, and ASTM 842 is for sliding doors. So again, these are prerequisite standards that are needed and required based on this standard ASTM F3561. So I'm going to talk a little bit about the first part of the testing of the standard, and that is the glass panel and lock weakening tests. So there are two means of weakening a weakening device for the standard. The first is the ballistic firing mechanism, and this is using an AR-15, which is a 5.56 rifle, that discharges a 5.56 NATO round, which is a 55 grain M193 for a metal jacket. The standard states there has to be a specific velocity range for this bullet, which is 3,337 to 3,403 feet per second. Here at our lab, we use velocity screens to measure that velocity, to make sure it's within that range as specified by the standard. Now, again, I mentioned there is another means to be able to create that weakening. Now, let me specify this alternative is only specific to the glazing pre-evaluation testing as part of Method B, Appendix X1.4 within ASTM F3561. So again, this is just for the glazing pre-evaluation testing that you can use as what they call the hole generation mechanism. So by using a tool such as a drill or a water jet cut, you're able to produce 6 millimeter holes that fully penetrate through the glazing. And these holes have to be identical to the pattern of the ballistic firing means. And I'll talk a little bit about that here in the next couple of slides as far as what that pattern is. This is something that again is offered as an alternative. This is something we have not performed at our Pennsylvania site. We've done the ballistic firing mechanism for all the weakening tests that we've done for this client. So again, the glass panel weakening has a specific pattern that you have to subject that specimen to, and you see that here in this illustration. 10 shots is what's required at the center of the specimen. It is a pattern diameter of 18-inch diameter, so you can see 8 shots there on the outer diameter, and then 2 shots at the center. And these shots, the projectiles, are to be shot in what's called a compass configuration order. So as you can see there in that one bullet item, you go north, south, northwest, southwest, northeast, southeast. So that is the order that you have to do those first 8 shots in. And then the final 2 shots, again, are at the center, the C1 and the C2. Now, one thing to point out here is that, when doing testing to this standard, you're not walking away with any sort of ballistic resistant rating. This is specifically weakening that class or that panel prior to the impact test. So again, you are not getting any sort of ballistic rating from this. You're just weakening that specimen prior to the impact test, which again, the impact test we'll talk about here in some further slides. So again, that was the glass panel weakening. Now there's again a lock weakening, or such as again a door. If you have a lock on a door, you have to go through what's called a lock weakening. And not as many shots as what you would have on the glass of the panel. You have 5 shots that would be done on the lock mechanism in a pattern diameter of 9-inch. So you have those 4 shots on the outer of that diameter, and you have 1 shot at the center. As per the standard, the pattern on the lock is offset so that to the right or left of the locking mechanism, so that either that westernmost or easternmost shot is centered on the lock. The shots are again done in a compass configuration order where you go north, south, west, and east, and then you have that 5th shot at the center. I'm sorry, let me take that back. You do the first shot at the center, and then you do your north, south, west, and east on the lock weakening. Again, to reiterate what I said on my previous slide, this is not receiving any sort of ballistic rating based on this testing. You were just weakening that lock prior to the impact test that would then be done on that component. So let's talk a little bit about the force entry testing section now of ASTM F3561. You can see there in that image there, you can see the impactor we use, and you can see there that is just a piece of glass that was weakened, obviously prior to us starting into the impact test with the 10 shots in the pattern I just described in my previous slides. So this here shows the actual impactor itself that's specified in the standard. Anyone that has done testing to ASTM F476, this probably looks very familiar. This is the same impactor that is detailed within that standard. The impactor itself is hung on a pendulum system for the testing and has a specific weight to be able to deliver these horizontal impacts. The steel cylinder is 6 inches in diameter, and then it has a hemispheric impact nose, or head form, as we call it, that is made from a polymer material that has a Shore D hardness of 80 plus or minus 10. And the weight of the impactor is 100 pounds plus or minus 2 pounds. So again, it suspends from steel cables in a pendulum style with a swing radius of 67 inches, as you can see there in those illustrations. So talk a little bit about the force entry and the protocol, the testing protocol itself. So the impacts are again done and completed after the weakening test has occurred, as mentioned previously. For force entry impacts that are being completed on or conducted on a glazed or fixed window system, you would do impacts at the center of that fixed window. Now, if it's a fixed panel system, then the standard states that you perform one impact at the center of the panel, one at the corner of the panel, and then one at the frame pocket. So again, if it's a fixed window, you would have 3 specimens, and you would have all 3 impacts done at the center of the glazing. If it's a fixed panel, you would perform one at the center of the first specimen, and you have another specimen that you do an impact at the corner of the specimen, the corner of the panel, and then you have a 3rd specimen that would be done at the frame pocket. And again, these impacts are all done and completed after the weakening has been done to these systems. So for a door system, again, impacts are completed again after the weakening tests have occurred. Force entry tests are completed on the door panel or glazing, as well as the latch and lock mechanisms. Double door systems will only have the main locking system evaluated by the impact test and not the point lock locations. And again, this is specified within the standard. All right, so we're going to talk a little bit about the level of performance based on ASTM F3561. So talk a little bit about what the actual pass-fail criteria is and about the levels themselves. So the impacts start at level 1. So to be clear, you can't come in and expect to start conducting tests at level 4. You have to start at level 1. They must start at level 1, and then you incrementally continue up through those levels based on it passing the requirements. So for level 1, you would start at the heights required, which you can see there in that little table I have, would be 6 inches. So at a 6-inch height is where you would start for level 1. You have to have 2 impacts pass. So the specimen has to pass 2 sequential impacts in order to move on to the next level. And the pass-fail criteria is it's a 6-inch non-compressible sphere, cannot pass through with no more than 4 pounds of force. So again, you would start at level 1. You would do 2 sequential impacts. If it would pass, if the 6-inch sphere would not pass through with no more than 4 pounds of force, then you would move on to level 2. You would go increase your height of the drop, as you can see, another 6 inches for that table. And then you again would have to perform 2 sequential impacts based on level 2, and then just continue on if, again, the product continues to pass the requirements. And again, level 1 and the highest level for the standard is level 8. For doors, as I mentioned, you have to do impact tests on both the glazing and panel as well as the lock itself. So if you have your 3 specimens you're testing for your door, and your first 2 specimens you conducted on the glazing and panel based on the impact tests, and let's say those 2 specimens achieved level 4, and then when conducting the impact tests on the lock itself, it only achieved level 3, then for that door system, that door would only qualify for a level 3 based on the lock achieving a lower level than what the glazing and panel did. So a few things that we've encountered so far, and again, I want to mention and clarify that, it's been a limited amount of testing that we've conducted at this point since this standard was published in August of last year. So, but these are some things that we've encountered so far in the tests that we've done. During the impact testing of glazing only, again, this is glazing only, these are the non-system tests, just the glazing. We've encountered some difficulties when establishing a failure with the current method that's using that 6-inch sphere with the 4 pounds of force. And what we've experienced is that as you're impacting that glazing, and the glazing again has already been weakened from the ballistic shots, when it's impacting that glazing, and if a tear opens up and the impactor is able to pass through, we've had it where the impactor has passed through the glazing and become lodged within that glazing, and in order to get it out, we have to use brunt force, and at times we have to use a sledgehammer just to beat it out to get that impactor removed from the actual glazing itself. So a proposed clarification that has been addressed with the ASTM committee for the standard is that when this impactor, and you can see the image there on the screen, when this impactor has become lodged and the head form, which is that front hemispheric shape on the impactor itself. So when that head form has become lodged and has passed through that glazing to the point where you can visibly see a portion of that rubber gasket where the actual head form attaches to the body of the cylinder itself. So when you can visibly see a portion of that rubber gasket where it has passed through and beyond the point of what we call the protected side of the glazing, then that would be deemed a failure. And the only reason, again, this is being proposed is because of what we see is that as we get further into this testing and as the test labs are trying to determine what a pass-fail criteria is, we have to be consistent with what failure is based on these tests. So again, this is a proposed clarification to the standard that has been addressed and has been brought up to the ASTM committee for this standard. One of the other things we've noticed in this testing within the lab is that, and the image to the right shows again the impactor and with it being suspended from the cables. And on top of that impactor, there are eye bolts that attach the cables to that impactor. What we've experienced is because of these impacts where we've had the impactor head that's going through the glazing, and that as a result of going through that glazing, just the brunt force of that impactor continually impacting that glazing and going through it. We've noticed that the steel machine eye bolts that we use to suspend that impactor have sheared off after continued blunt force from that impactor. So that is something that we've experienced within the test lab, and it's just a result of, again, this impactor that's, as it's going through there and becoming lost, and then we're pulling out, and then we're doing more impacts on it. It just continues to weaken those steel machine eye bolts that we're using to suspend that impactor for the testing. So those, again, a few challenges that we've encountered so far with the testing we've done up to this point, based on this test method. So that kind of is my portion of just an overview, quick overview of the test method itself, ASTM F3561. So what I'm going to do now is I'm going to transition this presentation over to Andy Holstein, who's going to discuss the Intertext certification and how it applies to the standard ASTM F3561. So if you want to go ahead and take it away, Andy.
Yep. Thanks, Travis. Intertext offers product certification to ASTM F3561 through our industry-recognized ETL and Warren Kersey marks. With the life safety implications of these assemblies, ongoing product certification with periodic quality assurance inspections is a vital tool to ensure that these assemblies installed in the field can be relied upon to perform as expected, whether they're constructed today, tomorrow, or years from now. The ASTM F3561 is intended to be an assembly-based certification standard due to the high degree of interaction between assembly components when subjected to the applied loading that Travis talked about. There are, however, two exceptions to this. The first, which was mentioned earlier, is Appendix X1 of the standard, which lays out a test method for pre-evaluating glazing products outside of a full system assembly. It is important to note that this method does not pre-qualify the glazing and does not in any way permit the glazing to be directly substituted into untested assemblies. It's strictly intended to be used as a pre-screening method to allow glazing and system manufacturers to identify appropriate combinations for full system testing. The second exception is Annex A1, which lays out a series of prescriptive substitution criteria that can be used to qualify untested assemblies. These substitution criteria may be used to expand the scope of Intertext certification beyond the tested assemblies. I won't be able to go over all the different substitution criteria during today's webinar, but I'd like to give you a brief overview. The first item that is important to note is that component substitution is only possible for systems that have first been fully qualified by the 3-specimen standard test method that Travis mentioned. Annex A1 categorizes substitutions into 4 distinct categories. Substitutions that are automatically permitted without testing or analysis, substitutions that are permitted when supported by engineering analysis, substitutions that are permitted when supported by a single specimen test, and substitutions that are not permitted without a full 3-specimen qualification test. The simplest category of prescriptive substitution is automatic substitution. This is permitted for attributes that have strong justification based on existing industry knowledge of expected assembly behavior. Examples include assembly size, where testing the largest and smallest desired assembly sizes grants all-inclusive sizes. Once again, that would be 3 specimens of the largest and 3 specimens of the smallest assembly. Substituting glass or interlayer colors is approved, an increase in the thickness of sacrificial lights and interlayers, and a replacement of monolithic sacrificial lights with a laminated unit. Engineering analysis is permitted to substitute fasteners within an anchorage method or change the anchorage method entirely. Substitute glazing sealants, adhesives, and backbedding. Substitute glass coatings when durability and compatibility are evaluated and determined to be adequate. And increase the quantity of locking points in operable assemblies. When supported by an additional specimen test, an increase in the thickness of non-sacrificial lights or a change in the type of non-sacrificial light is permitted. Changes in light type must move from top to bottom in the list on the screen. In other words, testing annealed glazing permits all of the other listed types, while testing fully tempered glazing does not permit any other type. Moving from a monolithic or laminated glazing system to an insulating glass unit requires an additional specimen test, as does decreasing the thickness of sacrificial lights or interlayers. Single specimen substitutions related to framing include a change in anchorage method, substitution of framing materials when the increased section moduli is appropriate, and substitution of rolling, sliding, hinging, or locking hardware. Finally, substitutions that are not permitted without a full 3-specimen qualification test include a decrease in the thickness of non-sacrificial lights or a change to non-sacrificial light type that moves from the top to bottom in the list on the screen. Insulating glass units may not be replaced with monolithic or laminated units, and the installation orientation of IGUs may not be reversed. Interlayer type may not be substituted without full qualification, nor can you reduce the quantity of locking points in operable assemblies. In summary, ongoing product certification with periodic quality assurance inspections is a vital tool to ensure that attack-resistant assemblies installed in the field can be relied upon to perform to the high standards of ASTM F3561. Certification in accordance with ASTM F3561 is assembly-based, but via the prescriptive substitution criteria in Annex A1, Intertech is able to extend certification to certain justified untested assemblies. This allows us to provide clients with an efficient manner of certifying a wider range of products while still maintaining a very high level of confidence that these assemblies will meet the performance criteria of the standard. At this time, Travis and I would like to thank you for attending today's webinar. And if you have any questions, please enter them in the chat window or contact us as shown on the screen. As Laura mentioned at the beginning of the presentation, we expect to respond to your submitted questions within 24 to 48 hours. Thank you.
Awesome. Thanks, Travis and Andy. That was great. And thank you everyone for joining today. Like Andy just mentioned, we will collect all the questions that came through and get back to you shortly. And also a recorded version will be emailed out to everyone and available on our website, hopefully later today, if not tomorrow. Thanks again.